Like I say, what we're going to have a look at is the function questions that you're going to be given in your papers in terms of the grade 11 functions, because that is where your marks are going to come for the functions questions. I said to you on Monday that unfortunately, when it comes to grade 12 functions, it's not the bulk of the marks in the functions section of your paper. The bulk of your marks is grade 11 functions, and so we need to be able to do it. Obviously, they can bring the inverse questions into a normal function question, like with a parabola or an exponential, but the bulk of your marks is coming from the grade 11 content. Okay, so let's have a look. What you'll see as you start to go through past papers is that they're, I would say order, because I can switch up the order, but their sort of go-to is a hyperbola, generally as your first question, a parabola and straight line, and an exponential, because the exponential tests, obviously, the log functions and so on. Parabolas and straight lines is generally where we can ask slightly harder questions like vertical distances and inequalities. And then the hyperbola is just a nice, straightforward entry-level question that everyone should get 4 marks for. So as you start to go through past papers, when you start to get ready for exams and stuff, you're going to see that generally it starts hyperbola, parabola, straight line, sometimes like parabola, exponential something, but parabola somewhere, and then an exponential function. So that's sort of what you can start to expect as you go through your past papers. But let's have a look at this first question. So this was from last year, September. So the trial exams for September, for the matrics rather. And as I've said to you before, your functions questions are generally questions 4 to 6, sometimes 4 and 5, but generally 4 to 6. Question 1 is your algebra. Question 2 is your 2 and 3 is your number patterns. Then you've got your functions, and then there's the finance, probability, and the other stuff that we're going to get to. So we've been given f of x is equal to 2 over x minus 5 plus 3. Right, now I say this every single time, and I'm going to say it again. When you are given a function, start by not answering the questions, but by looking at the function you've been given and assessing what type of function is it, what's happened to the function, do I have asymptotes, do I know what those asymptotes are, turning points, etc., etc. So this first and foremost is our hyperbola. Because that a value in the numerator is positive, I know that it means it's in quadrants 1 and 3. This hyperbola has been shifted 3 units up, and that's because of that plus 3 at the end, which means we have an asymptote at y equals 3. This hyperbola has also been shifted, 5 units right. And so we have an asymptote at x equals 5. Remember that your horizontal asymptote, this y equals 3, is dictated by the constant number there, whereas the shift left or right, so the vertical asymptote, is dictated by what's happening in your denominator. An x minus p expression is a shift to the right. An x plus p expression is a shift to the left. So because this is x minus 5, I knew I went 5 units to the right. So all of that information I've just taken from the equation. I haven't actually calculated anything yet. And 9 times out of 10, as you can see in the first question, they ask you for the asymptote equations. So we've already got those because we just took some time to establish what information we had. You're also probably going to have to sketch the graph, especially when they don't give you the graph. And so knowing what you're working with, which quadrants, asymptotes, and so on, it really does help you when you eventually get to that question of sketching the graph. So first question, nice and easy because we've already done it. Write down the equations of the asymptotes of f. We've got our vertical asymptote at x equals 5 and our horizontal asymptote at y equals 3. You obviously don't have to write down vertical and horizontal. I'm just going to put it there for us so that we remember that. And so that when we do have to sketch it, we know which is which. But that's all you need to do. These 2 equations, that was the only information I required of you for this question. 4.2 says write down the range of f. Now, because I did a little sketch for myself, I know what type of graph I'm looking at firstly, and I can start to gauge what the range should be. Now, remember, range are all of your y values that the graph exists. Now, we know that for hyperbolas, so we've got this hyperbola, we have that asymptote at y equals 3, and we know it sits in those quadrants. A hyperbola exists everywhere except for its asymptotes. So when it comes to the range of a hyperbola, it will always be y element of real, and then we just eliminate the y value that the asymptote is at. So in this case, y can't be equal to 3. That's all you do for the range of a hyperbola. That's it. The domain is very, very similar because, again, it exists for all of the x values except for where its asymptote is. So in this case, it would be x can't be equal to 5. So whenever you ask the domain or range of a hyperbola, it is always y element or x element of real, and then you eliminate the value that is your asymptote. Remember, if, say, for example, your x-axis is the asymptote, it's y can't equal 0. If your y-axis is the asymptote, it's x can't equal 0. So you just need to take note of your asymptotes, but it's every value except for your asymptotes. Okay, 4.3 is asking us to determine the coordinates of the x and y intercepts. Now, we've been doing this for a while, so does someone want to raise their hand, or does someone want to unmute themselves and tell me how we find an x-intercept and how we find a y-intercept? What do we do to go find those pieces of information? How do I find the x-intercept? How do I find the y-intercept? Can you see that? Nice. So x-intercept, we make y equals 0. Awesome. How do we, and then Clarice, nice, and num, nice. Y-intercept, we make x equals 0. Excellent, grade 12 is all done. So those are things you just have to remember. It's also the same for any graph that you want to work with. So any function, parabola, exponential, quadratic, which is parabola, I'm losing my mind today. Hyperbola, straight line, when we eventually do cubics. If you want an x or y-intercept, you will always follow this method. So we need to do both of these. Right now, generally, they're not particularly long calculations, but I'm going to start with the, let's start with the x-intercept. Just go alphabetically. This is now where we're going to make y equals 0. So 0 is equal to 2 over x minus 5 plus 3. And now we solve our equation. How you choose to do this is up to you, but I'm going to bring the 3 over to make it negative 3 is equal to 2 over x minus 5. And then because I don't particularly want this fraction, I'm going to times both sides by x minus 5. Because what that's going to do is it's going to get rid of my fraction, sorry guys, on the right-hand side. But I'm not getting rid of my variable. It's still there. It's just now on the left. So minus 3 times x minus 5 is equal to 2. We distribute, so we get minus 3x plus 15 is equal to 2. Inverse operations, minus 3x is equal to negative 13. And so the x-intercept is at a negative divided by a negative is a positive. So positive 13 over 3. As coordinates, 13 over 3 is 0. So that's our x-intercept. Our y-intercept is now where we make x equals 0. So y is equal to 2 over 0 minus 5 plus 3. So I want you guys to quickly finish that one for me. What is the y-intercept for this function? I've shown you the substitution. All you need to do is now finish solving. Nice, guys. Nice. Okay, so exactly, y is equal to 13 over 5. Now, personally, I prefer leaving it as a fraction. In this case, the decimal is 1 decimal point only, so 2,6. So it doesn't really matter. The reason I prefer to leave it as a fraction is A, if you do round off, you're obviously now making it inaccurate. And B, this is maybe just the way my brain works, 2,6, and then the semicolon of the coordinates between 0 and this 2,6 can get a bit confusing. So I would prefer to just leave it as a fraction, but if you write 2,6, that's obviously absolutely fine. You're not going to be marked wrong for that. I just personally prefer leaving it as a fraction. Right, so now we've got our x and our y intercept. Now, hopefully what you're seeing is this is guiding us to be able to sketch our graph, because they've made us identify the asymptotes, which we know we have to sketch. And they've made us find the x and y intercept, which, as you can see in the question, if you're going to sketch a graph, you have to show asymptotes, and intercepts with the axes. Those are the things you have to show when you're sketching a graph. And now we've got all of that information, so we can actually sketch it. The first thing I'm going to do is I'm going to sketch my asymptotes. Sorry, my brain had a brain fart there. So if I go and sketch my asymptotes, the y one was at 3. Now, obviously, guys, I'm just guesstimating here, and you will use a ruler when you do this. Asymptotes are always drawn with dotted lines. So please make sure it is a dotted line. So y is equal to 3, and then x is equal to 5. Vertical asymptote. And then we've got an x and y intercept. So the x intercept was 13 over 3, 0. 13 over 3 is something. 4,33 recurring, so we kind of need to get it there-ish. So I'm going to go 13 over 3, 0. And then my y-intercept was at, like we said, 2.6. So it's just below my horizontal asymptote. So 0, 13 over 5. And now you've got one arm of your hyperbola. Yes, there's our one arm. To get your second arm, you should always at least have one other point on there. You can just draw the general shape as you go along. And to get a point, you just substitute in a random value. Doesn't matter what value you substituted. Oh, excuse me. But I'm going to substitute in 6. So we've got f of 6 is equal to 2 over 6 minus 5 plus 3. 6 minus 5 is 1, so technically it's 2 plus 3, which gives me 5. So my coordinate that I need to plot is at 6, 5. And so I go and plot that. That is about there. You can plot more points if you want. Oh, gosh, I then went through the point here. But now you've got a coordinate on your second arm. You should always have at least one coordinate on each of your arms of your hyperbola. Sometimes it works out nicely that the x-intercept is on one and the y-intercept on the other. Sometimes it doesn't, like in this case. Then you just find a coordinate and you plot it. To find the coordinate, you pick an x value. It doesn't matter what x value because you're applying it in the rule of your graph. So whatever x value you choose, you're going to be fine. Okay, so that was our sketch. I feel like this might be a bit small now to take a screenshot, but hopefully we'll be okay. Let's take a screenshot of those first 4 questions and then we'll continue. Obviously, grade 12, please remember, if you've got questions, please ask either on the chat or you can unmute yourself and ask, but please do ask as we go along. Sorry, guys, I'm finished with this term. And now I see your question. So Nam's question was, how would the marks be awarded for the sketching? So in terms of your sketching marks, you would get a mark for your asymptote. You would get a mark for your intercepts. Come on. Okay. Cool. A mark for your intercepts. A mark for the general shape. We always give a shape mark. And you would get a second mark for your vertical asymptote. So 2 marks for your asymptotes, for your intercepts, and then for the shape. So even if like your plotting is a bit weird, but your shape is correct, you can still get 1 mark for your sketch. And that's why sketching graphs, when you're asked to do it, is such a, like, it's a mark bank. Just make sure you can sketch those graphs. It might be 3 or 4 marks, which in the bigger scheme of things is not necessarily a huge amount, but it's enough to make a difference. Okay, so you always get a shape mark. You then get a mark basically with characteristics we've asked you to label: the asymptotes, the intercepts, if it's a parabola, the turning point, etc. Righty. Okay, 4.5 says describe the transformation that the graph of f has had to undergo to form the graph of h, where h is equal to minus 2x. Oh, let's try those words again. Minus 2 over x minus 5 minus 5. Right, now there are actually 2 potential answers to this question. So let's just go back to what the original f of x graph was. So this was our original f of x graph, 2 over x minus 5 plus 3. Now, guys, it depends which transformation you see first at the end of the day. But there's 2 things that have happened to this graph that we need to bear in mind. Thing number 1 that's happened is now this fraction is a negative, whereas initially it was a positive. And the second thing that's happened is we've now got a minus 5, whereas before we had a plus 3. So there's definitely been a shift, and there's been a shift down because it's now at negative 5. And something's happened to make that fraction a negative. Okay, now how you choose to see this is up to you, because it depends on which way. Your answer will depend on which transformation you see first. Personally, I was working left to right, so I saw the negative first. Now, whenever that y value becomes negative, you've reflected over your x-axis. So remember, if you reflect over the x-axis, your y values become negative. And because I saw that negative there for the y value, because remember h of x is a fancy way of saying y, I knew that I'd reflected over the x-axis. Okay. Now, if you have reflected in the x-axis, what that would do to, sorry, I can't get my pen. What this will do to your original function is you will now have whatever the graph is, let's call it g of x for now, because it's obviously no longer f of x, but it's not yet h of x. We will now have minus 2 over x minus 5 minus 3, because everything of your y value, everything of your y becomes negative. Now we can compare where that, or how we've sort of got to this point with what happens next. This fraction stays negative, but this negative 3 becomes a negative 5. So that means we have shifted 2 units down. If we now take this pink graph equation that we've got and we shift 2 units down, I would have to subtract another 2. And that gives me the negative 5 that I ended up with. So if you see the reflection first, cool, apply your reflection. And what I quite like to do, as you can see, it's fighting with me, is particularly when there's multiple steps to your transformation, I like to write out the equation step by step so I can see how it's changed and I can see where I still need to go. So because I had seen what the change was with the changing of the signs, I knew that I just had to go down 2 units. Right, alternatively, if you had seen, or if you understood the fact that because of this negative in front of your fraction, you are going to be reflecting about the x-axis, you could then sort of go back and think, okay, well, I was already at positive 3. In order for me to get to negative 5, I could take the whole graph 2 units up and then reflect it over my x-axis. So what I mean by that is we could start with shifting 2 units up. And what that would do to my equation is as follows. Again, I'm just going to use a g of x. That would now be 2 over x minus 5 plus 5. Remember, I haven't yet dealt with the reflection. And now because I had that negative, I know there must be a reflection. I can say reflect about the x-axis. And so this is now where you will take your equation that you had, you will times it by -1 because the y's become negative. And so now you end up with your h of x is equal to minus 2 over x minus 5, which is exactly what they said h of x is. So it depends which transformation you see first. That's going to depend on how you answer this. But like I always say to you, go step by step. There is no need to try and do everything all in one go, especially when there are multiple transformations. Do it step by step and then you'll get your answer. All right, so I'm just going to stop there in case you need to screenshot. And then we'll have a look at the next one. And again, guys, remember, please ask questions as we go along. That's the whole point. Just keep asking me questions if you're feeling a bit confused. I know I've put the marks there and I'm not doing mark allocations. So if you do want me to do the mark allocations, please just ask. It's more so that you have an idea of how much working out you should show. But I'm happy to show you. You just need to ask me. Okay. So let's have a look at question 6. So in this case, that's English. This was question 4. Okay, whatever. Question 5 was then one of the exponential questions we did yesterday. And then they moved on to question 6, parabola straight line. So question 6 says the diagram below shows the graphs of f of x equals x squared minus 6x plus 11 and g of x equals ax plus b. The graphs of f and g intersect at S and T, where T is the turning point of F. The angle of inclination of G is 63,44. Now again, whole bunch of information. Let's actually first go to our graphs and see what's what. So this purple graph that I'm going over here, this is our parabola. So this is our graph of f of x. The straight line, is your g of x graph. Now, guys, obviously you can see this on the graph. The graphs have been labeled. The graph should always be labeled. You can see the g and the f on your graph, so that's okay. The graphs intersect at S and T. Again, we've been given those points. Here's S, here's T, but very importantly, T is my turning point of this parabola. So whatever this coordinate is, that is the turning point of the parabola. We're then told that the angle of inclination of G is 63,44 degrees. Now again, if you have a look, that's given to us. Here's our 63,44 degrees angle of inclination. Now, before we go any further with this, what I want you to remember is that angle of inclination comes from analytical geometry. And it says to us that tan theta will give us our gradient. So if we want to work out the gradient of a straight line, and we measure the angle from the x-axis to wherever that straight line is, that angle, if we now use the tan ratio, so shift tan, we will get the gradient of our straight line graph. Now, again, we don't give you useless information, so all of this is going to have to be used at some point. But the first question asks us to calculate the coordinates of t. Okay, so t is your turning point. I'm going to make this bigger. Now, there's two ways that you can do this, grade 12s. The first way is to complete the square, which I don't know how many of you would choose to do because it's not something stereotypically we like. Completing the square is just not something most matrics enjoy doing. I'll be honest, I don't particularly enjoy it either. And so you don't have to use that method. Remember that the x coordinate of your turning point is found by the little formula minus b over 2a. And if you remember that, you can find the coordinates. Your graph must always be in standard form to use this. In this case, our graph is in standard form because it was given to us as x squared minus 11x, minus 6x plus 11, sorry, minus 6x plus 11. That's standard form. Standard form would be ax squared plus bx plus c. And then you just go and find your x coordinate. So minus b would be minus 6. over 2 times a, so 2 times 1, minus 6 is plus 6. 6 divided by 2 is 3. So the x-coordinate of your turning point is positive 3. You now want to get your y-coordinate. So you will sub it back into your original function. So 3 squared minus 6 times 3 plus 11. And so where x is equal to 3, your y value is 2. So the coordinates of your turning point are at 3, 2. Now, if you look at your graph, you can see that it is sitting above your x-axis and to the right of your y-axis. X is positive, y is positive. The answer that I've gotten makes sense for the graph I've been given. I don't know what's happening. Sorry, guys. Okay. T is at 3, 2. Now, I always like to just write in my coordinates as I find them. Oh, technology. Just because it's an extra piece of information that I now have and can potentially use. Yes. I'll be honest, I didn't even think of it purely because we have yet to do calculus. So yes, you can find your first derivative. What would that be? 2x minus 6, make it equal to 0, and then you can solve for x, sub it back in. Absolutely fine. Yeah. So guys, if you've already done calculus at school, you can use your first derivative to go and find your turning point. Like I say, I didn't use it here because we, MathsLive, have not yet done calculus. But if you have done it and you're comfortable to do it, absolutely, there's no problem. So there's 3 ways to do it. Complete the square first derivative, and then x of your turning point is equal to minus b over 2a. Okay, so there are 4 marks allocated here. Obviously, the mark allocation now does differ depending on the method that you use. For this method, it would be substituting into your turning point value formula, getting your x, subbing back, getting your y. Right. Again, methodology depends. You do what you're most comfortable with. That's the beauty of math, is different ways to do the same thing. So question 6.2 says, determine the equation of g in the form y equals mx plus c. Now, g is a straight line. We're happy that y equals mx plus c is the straight line general formula. So that's all we need to do. Now, if we go back up to our straight line, stupid thing. If we go back up to our straight line, the only piece of information we now have about our straight line is the value of t, which is just a random coordinate on my line, which is fine. It's on the straight line, so that's okay. But remember, you've also been given the angle of inclination. And the angle of inclination allows you to find m. So that's where we can start. So our angle of inclination was 63,44. Is it not lying to you? Let's just make sure. Yes. And we know that tan theta is equal to the gradient. So that means tan of 63,44 is equal to the gradient. And then you just put that in on your calculator, right? You don't have to do anything. So m is equal to 2, I think it was 2,000. If you round that off to 2 decimal places, it's just 2. Generally speaking, that's what you'll do, because your gradient, we generally want you to work with a nice whole number, or at least a nice simple fraction. So we now know that y is equal to 2x plus c. And because we know that t is on this line, we just sub in t. And we can solve for our remaining variable c. So I want you guys to do that for me. I want you to sub in t, and I want you to solve for c, and thereby give me the equation of that straight line. Nice, guys. Okay, good. So we're going to sub it in, giving us 2 is equal to 2 times 3 plus c. 2 times 3 is 6. 2 minus 6 is negative 4. So y is equal to 2x minus 4. Very, very nice. Well done. All right, so that's only 3 marks. The marks coming in for using your angle of inclination, substituting in your point t, finding the equation. Again, not a lot of marks, but remember, all of those add up and could potentially be the difference between your pass or failure, your 60 or 70, your 70 or 80, or 80 or 90, blah, 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 blah. So we want to try and get as many of these easy marks as we can. Right, if we get to 6.3, it says hence or otherwise determine the coordinates of S. So let's go back up to our graph and let's discuss what S is. So who can tell me what S is in the context of this question? What point is S? Nice and it is a point of intersection. Now, how would we usually solve to find the coordinates of a point of intersection? What would we do? What's our method? How do we find points of intersection? Nice, and you're on it. Exactly, guys. We equate the graphs. Now remember, you have just worked out the equation of your straight line, and you were given the equation of f of x of your parabola. So you have all the information you need to go and equate these two graphs. So that's exactly what we want to do. So f of x, oh, silly thing, was the x squared minus 6x plus 11. G of x you've just worked out to be 2x minus 4. Now, really importantly, guys, they have specifically said here the coordinates of S. What that means is we have to find both x and y. Sometimes they will ask you determine the x coordinates of S. And then you don't have to do the extra step of subbing that x value back and finding the y. In this case, they do want both. So read your questions carefully, because if they only ask for x, then you stop at x and you don't need to carry on. Right, so I'm going to give you 2 minutes. I want you to solve this equation, and I want you to tell me what your coordinates of S are. You maybe need more than 2 minutes, but I'm going to give you some time. I want you to solve this equation and tell me what is S's coordinates. Okay, I'm going to give you another minute or two and then we'll have a look. Obviously, again, feel free to ask questions, put your answers in the chat. But this is the time now to ask. Alrighty, let's have a look. If you're not done, don't stress. You can just sort of pick up from wherever you stopped. Snip my eyes. Yeah, that's cool. Right, so the first thing that we have to do is we have to get this into standard form. So we have to make one side equals to 0. So that will mean we've got x squared, bring the 2 over, so minus 8x, bring the 4 over, plus 15. Then we factorize. Now remember, grade 12s, you do have your quadratic formula. And honestly, if you're not super confident with factorization, just use the formula. So your formula is minus b plus or minus c 2a. This is on your formula sheet, so you don't have to learn this off by heart. It's on the formula sheet that you'll be given at the end of the year. And like I say, if you're not confident when it comes to factorizing quadratics, just use the formula. It will always give you the right answer as long as you substitute incorrectly. This quadratic, however, is relatively easy to factorize. It's x minus 3, x minus 5 is equal to 0. And so you get x is equal to 3 or x is equal to 5. Now remember, we now need to decide which one fits best with S. If you go back up to your graph, you've got 2 points of intersection. You've got the point of intersection that is S that we are working with currently, but you also have T, that's a point of intersection. T's X value was 3. So that means when it comes to these X coordinates that we've worked out, we already know where that 3 belongs. So that means we only need to work with the X equals 5. Okay, we now sub it back in. You sub it back into F or G, it doesn't matter. I would choose G, so I would always choose a straight line because that's the easier of the two equations. So 2 times 5 minus 4, which gives you 6. And so the coordinates of S are 5, 6. Okay, so points of intersection, like I say, sometimes they just ask you for the X coordinates, so read the question carefully, because then you would stop at that point. You wouldn't need to go further, but they don't always. The next thing I just want to say in terms of this, if you are going to use the quadratic formula, you have to show the substitution to get your marks. So I don't need to see a step-by-step working out. You can put it in your calculator, but you have to show the substitution. If you are not going to use the quadratic formula and you're rather going to factorize like I did, I have to see the factorized product. So I have to see the 2 brackets. You can't, unfortunately, go straight from the trinomial to the answers. You have to show me the brackets in order to get full marks. Right, so just bear those 2 things in mind as you go along. 6.4 is now saying to us, or giving us a bunch of inequalities. So, the first one is saying determine the values of x for which f of x is less than equal to 6. Now remember, f of x is just a fancy way of saying y. So it's asking where are the y values less than equal to 6. So we go back up to our graph. Now remember, I'm just going to take these squiggles off. We have just worked out that this is 5, 6. And we have just been given an inequality where the y value is 6. So I'm very much focused on this point S here, because anything above this is greater than 6. Anything below this is less than 6. And that obviously makes no sense. Greater than 6, less than 6. Our inequality asked, where is it less than 6? So basically, we care about this bum part of the parabola, the curvy part of the parabola. It's now gone. It's fine. I know the x coordinates at point S, that's 5, but I need to work out what this other coordinate is over here, because this also has a y coordinate of 6. And I need to essentially have an inequality that goes from one coordinate to the other. Now, you have no information about this point. You don't know where it is. It's not like it's a point of intersection or anything like that. But remember, with a parabola, we have this really cool feature of symmetry. So what I mean by that is, anywhere on your parabola, if you go to the turning point, your turning point acts as a mirror line, a symmetry line. If you fold your parabola over that line, you will create a mirror image. So that means whatever the point is on one side, if you create the mirror image, it will have the same y coordinate on the other side. This is on the same horizontal line, and that's why I'm saying that has a y coordinate of 6. So what that means is we need to go and solve for that x coordinate. We need to go and figure out where that x coordinate is. Now, because of this symmetry, I'm just going to draw a line through my turning point. Because of this symmetry, we can just determine how far away it is from the turning point. If I can figure out how far S is away from the turning point, it is equidistant on the other side. That's the beauty of a mirror image. It's equidistant. So my turning point we worked out to be 3, 2, which means if I'm starting at 3 on my x-axis and S is at 5, the distance between those 2 points is 2 units, which means the distance from T to this mirror image point over here is also 2 units, which means that if we're starting at 3 and we're going to the left by 2 units, this has an x coordinate of 1. And so now we've got our 2 x coordinates whereby the graph is less than 6. I'm just going to write this inequality here. And this would be between 1 and 6. So one of the important features that we often forget about parabolas is this feature of symmetry. And the symmetry is based around your turning point. If you can figure out the distance from the turning point to another x, you just go the other way, the same number of units to get the symmetrical point. And this is really useful, particularly when you're working with things like x-intercepts and so on, or something like this. Remembering that feature of symmetry is really, really important. Okay, so I'm just going to take a second. Does anyone have any questions about that? I know it's not the easiest thing to work with necessarily, but like I say, symmetry is very useful when it comes to parabolas. No? Okay, no problem. That's all right. Don't have to have questions. And what other way could you work it out? And unfortunately, because we don't know anything about that mirror image point, there would be no other way that you could work it out. You would have to use symmetry. I would have to give you information about that coordinate in some shape, sense, or form in order for you to work it out any other way. But in this case, you have to use symmetry to get it. Sometimes you don't necessarily have to use symmetry. There's a longer way to do it, or you can do it via points of intersection or whatever, or depends on the graph. But in this case, because it is quite literally a random point on the graph and we don't know anything about it, the only way for us to get there is symmetry. All right, the other the other question here at 6.4 says, determine the value of k, which f of x plus k will have real roots. Now, this is one that they ask you all the time. You either get these questions or you don't. I'm going to be honest, I don't particularly enjoy these questions. I find it quite hard to conceptualize. They're not hard questions, but they are hard to conceptualize if you don't fully understand what they're asking. So let's just Let's just take a quick little moment A parabola can have a number of different types of roots. So firstly, roots are determining, or rather talking about where it cuts the x-axis. So if your parabola cuts your x-axis twice in two different places, this is two distinct unequal roots. We can then have a situation where we have equal roots. I'm panicking a little bit, so we're just going to correct here. Equal roots would now be where your parabola turns on the x-axis. So this would now be two equal roots, because you still have two values there because it's a quadratic, but they just happen to be equal. And then you have a situation where you have non-real roots. And this is where your turning point is sitting above or even below your x-axis if it was a sad parabola. Okay, so this would be non-real roots. I don't know what's happening here. Non-real roots. You can just ignore the graph there. I put it there in case we needed it again. So those are sort of the three situations that you need to deal with when it comes to roots. If we go to our graph as it currently is, what you can see is that this parabola is sitting above the x-axis. It's not cutting the x-axis. So right now, this graph of f has non-real roots. So the question is asking us, what do we need to do to the graph to make it have real roots? And it specifically said, or gave us an expression of f of x plus k. This plus k is a constant, and because it's a constant, it's relating to an up-down shift. So basically, it's asking me, by how many units up or down do I need to shift this graph so that it has real roots? So if I go and let's do this. So here's my parabola. Okay, beautiful parabola. If I take this parabola and I carry on shifting it up, it's going to continue to have non-real roots. The further I shift it up, it just keeps having non-real roots. What I need to do in order for it to eventually cut the x-axis, I need to move it down. If I move it down, I'm eventually going to get to a point of equal roots. It's just touching the x-axis. And if I keep moving it further down, I can see that I now have real roots. I actually get x-intercepts here. Now, these sorts of questions always relate back to your turning point, okay? Because your turning point is the lowest or the highest point of your parabola. In this case, my turning point, because we've worked it out, is 2 units away from the x-axis. So as long as I move this graph at least 2 units down, I'm going to be fine. As long as it goes at least 2 units down, I will be okay. It can go 3 units down, 4 units down, 5 units down, whatever. But as long as it goes just more than 2 units down, we will have 2 distinct roots or 2 real roots. So what that means is a movement down would be indicated by a -2 value. Now remember, f of x was x squared minus 6x plus 11. I need to move it 2 units down. So I'd be adding a -2. So as long as k at least is -2, we will have real roots, and it has to be less than or equal to -2. Now, why less than -2? Less than -2 keeps going more and more negative. So it'd be -3, -4, -5. That means 3 units down, 4 units down, 5 units down. That's exactly what I want. I don't want to go only 1 unit down, because then I still have non-real roots. 2 units down puts me on the x-axis. That's still a real root. Yeah, it's the same. It cuts once, but it's still a real root. And anything more than that, so -3, -4, -5, will give me those real roots. And so that's how you need to approach these questions, with the idea that we're talking about a turning point, and with sort of this summary in mind of where do you have equal roots, non-real roots, etc., etc. Now, I get that this is not the easiest question to comprehend. I really do. I personally also really struggle with these questions, but they do ask them. And yes, it's 2 marks, so it's not like you're losing a huge amount, but it's 2 marks that you can get. And so if we can get them, let's get those marks. Right, I think this is actually a bit small. So what I'm going to do is I'm going to do up to 6.2. You can take a screenshot, and then I'll go back to 6.3 and the rest of them.